The sound of a rainstorm. Many people find it relaxing. To some fish and animals, however, it could be the sound of death slowly approaching. An increasingly important environmental problem in the world today is acid deposition. Most people have heard of acid rain, but that is only a part of acid deposition, which includes acid rain, acid snow, acid hail, and even acid fog. Automobiles, forest fires, factories, volcanoes, and electric power plants. What do all these have in common? They all belch toxic gases into the atmosphere. These toxic gases, more specifically sulfur dioxide and nitrogen oxides, are what cause acid deposition. Clean air is 99% oxygen and nitrogen. The other 1% is made of carbon dioxide, water, dust, methane, helium, and krypton. When the air is polluted, acids form. While some sources of toxic gases are natural, such as forest fires and volcanoes, others are what are known as anthropogenic, or an influence to the environment as a result of human activity. Anthropogenic gases cause 95% of all acid deposition, and anthropogenic gas sources produce nearly 7 times the amount of sulfur dioxide as natural sources. In fact, according to the Environmental Protection Agency, or EPA, in the US, roughly 2/3 of all sulfur dioxide and 1/4 of all nitrogen oxide comes from electric power generation that relies on burning fossil fuels. Obviously, this problem arises anywhere where industrialization has taken place. Once the toxic gases are in the air, they convert to acids and combine with the precipitation, fall to the earth as dry deposition, or move in the air currents to another location, sometimes traveling great distances. Acids carried in precipitation are the most devastating in summer and at the end of winter. In summertime, the mixing layer of air is at its largest, and acids can form in relative quickness. Over the course of winter, acid snow accumulates and concentrates. Then, when the snow melts, all the trapped acids are released into lakes and streams. On the pH, or potential hydrogen scale of acidity, distilled water is ranked at 7, neither acidic nor alkaline, but completely neutral. In contrast, concentrated lemon juice is highly acidic with a pH of 2. Clearly, the higher the pH value, the less acidic a substance is. Normally, rainwater is slightly acidic at 5.6 because carbon dioxide dissolves into the water to form carbonic acid, the same substance in carbonated soft drinks. In the US in 2000, the acidity of rainwater dropped as low as 4.2. The acidity of precipitation is a major factor in the acidity of lakes and streams. When acids fall into a lake, for example, the acidity of the lake drops. Unfortunately, every plant and animal can tolerate only a certain level of acidity, and as the acidity drops, the organisms begin to die. As you can see, the spring peeper, a type of small tree frog, develops normally in water that is pH 7, but when the acidity is increased to 4, the embryo coils abnormally and fails to hatch. Frogs are one of the more resilient animals. When the acidity of the lakes drop to 5.1, the lake trout becomes thin and weak due to a lack of food, and they cease to produce young. The effects of acid deposition expand to plants as well. When acids fall in forested areas, the water is absorbed in the soil, and, depending on the ability to neutralize the acid, known as the soil's buffering capacity, minerals that can harm the tree are released. Also, especially in mountainous regions where atmospheric acids accumulate, acid fog bathes the trees in acid for extended periods of time, stripping them of the nutrients in their leaves. Here you see these effects on a forest in the Jezera Mountains of the Czech Republic. This can be devastating to the agricultural market. Maple trees exposed to acid deposition become unhealthy, causing a decline in maple syrup production. Also, acid deposition on crops has been directly linked to declines in crop yield. The effects of acid deposition extend even farther to affect humans directly. The same particulate matter the acids form from can easily be inhaled, causing cancer and respiratory diseases. One less known fact is that acid deposition, especially acid rain, has been linked to damage in automotive coverings. In fact, US auto manufacturers spend $61 million every year applying protective coatings to cars. A little ironic seeing as the auto emissions play a major part in the problem. In addition to corroding cars, acid deposition can damage monuments and buildings. When sulfuric acid comes in contact with the calcium components of stone, such as limestone, sandstone, marble, and granite, it alters the chemistry of the rock and creates gypsum, a soft flaky mineral which falls off. Thus, the stone is damaged, such as this one. Notice the look of pain on the statue's hardly distinguishable face. Iron corrodes quicker when exposed to acid deposition, and visibility is reduced in areas plagued by this problem. The LA smog is a perfect example. As scientists and the general public learn more about acid deposition, the need for prevention becomes more and more apparent. That is why preventative techniques have been developed. The only way to reduce acid deposition is to attack its primary source, pollution from energy production in cars. Back in 1970, one solution was to build the world's largest smokestack, but all that accomplished was moving the pollutants into the fast-moving airstreams of the upper troposphere. There are three main ways to reduce pollution: clean up the smokestacks, use alternate forms of energy, and take action as individuals. Coal is the most common fuel for power plants because there's so much of it, enough to last for the next 200 years in fact. However, coal is also the dirtiest of all the fossil fuels. When burned, it emits carbon dioxide, sulfur dioxide, and nitrogen oxides. However, nitrogen is present as an impurity and can be taken out before burning. Also, devices called scrubbers can chemically remove sulfur dioxide from the gas stream. Much like scrubbers reduce sulfur dioxide emissions from power plants, catalytic converters reduce nitrogen oxide emissions from cars. While coal is the most common form of energy, there are others. The cheapest forms of energy are nuclear, hydroelectric, and coal. Renewable sources like solar, wind, and geothermic are also available, but their high cost makes them impractical. Alternate automobile energy sources are also being developed and are becoming increasingly popular. Natural gas, batteries, biodiesel, and fuel cells are all examples of developing alternate fuels. The third way to reduce acid deposition is to take action as individuals to conserve energy. Turn off the light when you're not using it. Use natural light as much as possible. Carpool. Ride bikes. Simply find ways to reduce your use of energy. Ultimately, you've already taken the most important step. Become informed about acid deposition.
Listen to the rain. Here it comes again. Hear it in the rain. Feel the touch of tears that fall. They won't fall forever. In the way the day will flow.